Okay guys, let's take a look at measurement part 4. In part 4, we're going to look at SI units, which is known as the System of International Units, more commonly known as metric prefixes. Okay, in looking at our quantity for measurement, let me get my pen here. When you're measuring the length is going to be abbreviated with a lowercase l. If you wanted to measure the length of something, our base unit would be meter, and meter is abbreviated with an m. If you wanted to measure the mass of an item, mass is going to be abbreviated with a lowercase m. The base unit for measuring mass is grams, and grams is abbreviated with a g. If you were measuring time, time is abbreviated with a lowercase t, and you wanted to measure time, you would use seconds, and seconds is abbreviated s. If you were measuring the volume, which is abbreviated v, you would use liters for a base unit, which is represented with an L. Some other units that you should be familiar with that we'll use: temperature, abbreviated with a capital T, Kelvin, which is K. We'll also use degrees Celsius. And then this is a big one for our class. The amount of a substance is abbreviated with a lowercase n, and it's measured in moles. Chemists measure amounts in moles, and we'll have more on that later. So when we're looking at our base units for metric conversions, they represent the number 1. So as we look at our metric prefix chart, we need to understand that when we're referring to the base unit, they're representing the number 1. In other words, 1 meter, 1 liter, 1 gram, and 1 second. And then we can add prefixes to any one of our base units, and that's going to make our value larger or smaller depending on the base unit that we're using. Okay guys, in class on Tuesday you received a metric conversion chart, had the prefixes on it. If you would pause the video and grab your chart real quick, we're going to use that as we continue through the rest of these notes. Okay, so hopefully you've got your charts out with you. Let me get my pen. All right, notice here we have the base unit. Our base units can be meter, liter, grams, seconds, and there's other base units, but these are the main ones that we're going to use. And remember, their value as a base unit is a 1. So 1 meter, 1 liter, 1 gram, or 1 second. And they would fit right here on our chart. So you could substitute the word meter for base unit. You could substitute liter, gram, whatever base unit you're using, you could substitute it right here. And again, these have the value of 1. And then anything above the base unit, any prefix above the base unit, these have a value larger than 1. So these prefixes over here, these are representing big amounts, much larger than 1. And then below the base unit, these are small. These have values smaller than a 1. So these are tiny. One thing I'd like you to notice when we look at this, deca versus deci. Deca is above the base unit. It's larger. Deca represents the number 10. And it's abbreviated DA. Deci is a smaller number than 1. It represents a tenth. To keep deci and deca separate, remember deca, bigger than 1, so it's got more letters. DA versus D. Deca's big, so it gets more letters. Deci's small, he's only one letter D. Deci represents a tenth. Deca represents 10. Just a little way to help keep those two straight. Okay, this is the same chart. Look at just our larger prefixes first. So again, I have my base unit right here. And then all the prefixes above it are larger than the value of 1. And you guys have to know the name Deca, its abbreviated DA, and then its value is 10. You would have to know that hecto is abbreviated H and its value is 100. You would have to know kilo is K, its value is 1,000. Mega is capital M and it's 1,000,000. And once I hit mega, I start using scientific notation. All right, so if I have my base unit representing 1, then again, if we add these prefixes onto the base unit, it changes the value. So let's look at an example. We know that hecto, H, is representing the number 100. So if you have hecto prefix added onto something, you've now made that value much larger. So when I look right here at this example hectogram, I say I have 1 hectogram, but you know a hectogram's a lot because hecto means 100. So in terms of how large is this hectogram, 100 grams would equal a hectogram. And this is just abbreviated. 100 grams is equal to 1 hectogram. Kilo means 1,000. Again, that's much larger than my base unit. So when I add kilo prefix onto a base unit, I've now increased that value much larger. It's now 1,000. So when I look at an example, a kiloliter, that's telling me if I have a kiloliter, then how many liters would I need? How many base units? I would need 1,000 base units. In this case, 1,000 liters. 1,000 liters is 1 kiloliter. If I change my base unit to meters instead of liters, if I had a kilometer, then again, adding kilo to that base unit of the meter just made that value go up. It's much larger. How much? I would need 1,000 meters to equal the 1 kilometer. In looking at our smaller prefixes, again, below the base unit, these are smaller than 1. Here's my base unit. Okay, these are going to be a piece of that whole. Okay, these are representing values, again, less than 1. So if I wanted to make these equal to each other, then I'm going to have a lot of those little pieces. Let's look at an example. Centi, which is C, is 100th, 0.01. That's 100th of a whole. My whole would be my 1. So if I had, go up here to our example, 100 centimeters would equal a meter. So here's my base unit, 1 meter. Here's my base unit at 1 meter. How many of these little centis do I need to equal that base unit? Well, centi means 100th, so I need 100 centimeters to equal my 1 meter. And this is just abbreviated, 100 centimeters equals 1 meter. If I was using micro, and micro's symbol, you guys, this one's a little odd looking. It's called a mu. It's kind of like a cursive U with a long tail to it. But it's known as a mu, and that's the symbol for micro. Micro, you'll notice, is a millionth. It's really small. So it's really, really small. If I wanted to equal one of my base units, how many of these little tiny, tiny pieces do I need to equal the one whole? I would need 1 times 10 to the 6, or 1 million micrograms to equal the 1 gram. Again, micro is really small, so if it's smaller than 1, I need a lot of pieces to equal that base unit. If you look at, excuse me, looking at your base units, you again could put meter, liter, seconds. Okay, that can change. If you're trying to equal one of them, if these are smaller than 1, then you're going to have more of them, more of your prefixes to equal the 1. That's why we need more of our prefix. There's our centimeter. I need 100 pieces, 100 centimeters to equal that 1 meter. Some practice right now. Now what I'd like you to do is, using your reference sheet, to go through and answer these. You'll need to pause the video for a moment so that you can answer. At the top, you're looking at your units and telling me, what is the unit measuring? And I gave you an example here, 500 grams. Okay, grams is going to measure mass. So I want you to tell me, what are you measuring in these first 6? Then at the bottom, 7 through 12, you guys are trying to work on knowing your metric prefix values. And so wherever there's a question mark, see if you can come up with the value. Okay, again, using your reference sheet. If you'll pause the video, and then we'll come back and go over them. Okay, let's check our answers. On number 1, we have the prefix milli attached to our base unit liter. Milliliters measures volume. On number 2, we just have grams, which measures mass. Number 3, we have our prefix milli attached to our base unit meter, so a millimeter is measuring length. On number 4, we have our prefix kilo attached to a gram, so kilogram is measuring mass. Number 5, I have the prefix milli attached to my base seconds. That's a millisecond, which is measuring time. And then number 6, my prefix centi attached to the base unit meter, so centimeter is measuring length. And then at the bottom, when you had to come up with the values, we have 1 megagram on number 7. And mega, remember, megagram, mega's big. So I need a lot of my base unit to equal that megagram. How much of my base unit? The value of a mega. 1 million, or 1 times 10 to the 6 grams to equal 1 megagram. On number 8, I'm looking for how many millimeters to equal a meter. Well, I know that a millimeter, I know milli's small. It's 1,000th. So I need 1,000 little millimeters to equal my 1 meter. On number 9, 10 deciliters. Okay, deci, remember, was small. I have 10 of those small pieces to equal my 1 base unit, 1 liter. You can think deci-dime. Dime is 1/10 of a dollar. Deci-dime, 1/10 of a dollar. Might help. All right, for number 10, I have a meter, and I want to know how many centimeters that is. Remember, centi is small, so I need to have how many of those small centis. Centi means 100th. I need 100 centimeters to equal my 1 meter. Kilogram, how many grams? Well, kilo, remember, is very large, so I need a lot of my base unit. I would need 1,000 grams to equal a kilogram. For number 12, I have 1,000th of a gram. So, or excuse me, 1,000th of a kilogram. So now I'm looking at a part of my kilogram. Remember, kilo is big, but I'm looking at the 1,000th of it. That means I'm looking at only 1 gram.